Hello, you guys. Well, welcome to my channel. Today we'll be going over a few questions from the practice exam number 2 of the official website, gmat.com. Hope you like it. If you have any questions, please don't hesitate to leave me a comment down there. And the timing, I highly recommend you to pause the videos, try to do these questions on your own, and then run it and see how, what I did differently than how you would approach it, and whether the method you used is the most efficient way you use, and maybe pay attention to the details and then, the comments I'm going to leave during and after each question. Okay, let's go. So the first question here is, it states, if x times y is equal to 1. So the minute I read this, I'm thinking to myself, okay, what does that mean? For x times y to be 1, they could both be 1s, or they could both be negative ones, right? Or it could be, one of them could be 3 and the other one could be 1 over 3, for example. But I'm not going to stop on it too much. I'm not going to pause at it too much. I'm going to continue. What is the value of this fraction with powers? So this is an easy one. Why is it an easy one? Because it's a fraction with the bases are the same, right? And we know when we have the bases are the same, we can actually rewrite this fraction as 2 to the power of x plus y, the whole thing squared, minus x minus y, the whole thing squared, right? So at this time you might think to yourself, oh, what is this? How is xy going to help me, right? So what I want you to recognize, every single time you see x plus y squared, and whenever you see xy is equal to 1, remember, when you multiply this out, you're going to get xy in it, right? So this is the link. This is, to calm you down. Oh, I know how to do it. This is if I expand, it's going to be x squared plus 2xy plus y squared, and then minus, this side is also going to be x squared. It's going to be minus 2xy, excuse my writing here, minus or plus y squared, right? So if I just subtract the like terms, so x squared minus x squared is going to go to 0, so these will go away. And then y squared minus y squared is going to go also away. And then 2xy minus negative 2xy, sorry, I missed the xy here, is going to be basically plus. So minus negative 2xy is going to give me 4xy. And xy is given as 1. So this is going to be 2 to the 4th, which is equal to 16. So this is it, right? So this is basically recognizing the terms, knowing the rules of division when you have the same bases, and recognize whenever you see x plus y squared or x minus y squared, or the difference of two squares, recognize them, and also recognize when you multiply it through, recognize this information here, right? So for example, for x squared minus y squared, which is the difference of two squares, do not only recognize this, but also recognize if you see x minus y times x plus y, right? So even if you see something like here, recognize it. Why am I telling you this? Because one of the easiest questions you could see in the GMAT is something like square root of 3 minus square root of 5 times square root of 3 plus square root of 5. Well, if you're going to multiply this, it's going to take you a very long time, right? If you're going to say square root of 3 times square root of 3, square root of 3 times square root of 5, and so on, it's going to take you a long time. But they're giving you this because they want to see if you're going to recognize that this is the right side of the difference of two squares, and this can be solved quickly by saying it's square root of 3 squared minus square root of 2 squared, the difference of two squares. And this is going to be 3 minus 2, which is 1. So recognize these equations, recognize the x squared minus y squared, and also recognize the right side of it too, right? So let's move on. Hope you get this right. Okay, let's move on. And as you know, the first few questions in the GMAT are important to get right. Because as you answer questions correctly, you're going to get more difficult questions, which are worth more points. Okay, so this one is a sequence question. If each term in the sequence, and they give you the terms, a1 plus a2 plus, and then the last one is a sub n, right? And these terms can either be 7 or 77, and the sum of all these terms is 370. Which of the following could be equal to n? So this is a sequence. When you have a sequence, the numbers underneath it, this is like a placeholder. So basically what this is telling me, that this one is basically the location of the term in the sequence. So they're telling me here, all these terms, I don't know how many I have, right? If I add them up, right, I'm gonna get 350. And they're telling me that the terms, the actual numbers in these locations, are either going to be 7 or 77. So let's say if I have n of these 7s, so if I'm going to add 7 plus 7, n times, it's the same thing as 7 times n. And if I have m numbers, m 77s, then it's the same thing. So this is the sum. Instead of adding 77 m times, I'm just going to multiply it by m. So this is equal to 350. So algebra also always comes in, to the rescue. So with this one, we can take the 7 out as a common factor, or we can divide both sides by 7, and we're going to get n plus 11m is equal to 50, right? So basically, now we want to know what possibilities do we have. What possibilities do I have? So I look at this one and recognize that n and m are basically integers, positive integers. They are the number of 7s and 77s that we have. So basically this whole term here, if m is 0, which is not a possibility because they didn't say 0 is a possible number, I mean, maybe we can have, let's keep the 7 in, because what if we don't have any 7s? But in reality, most probably we will have it. So let's say if m is 0, this term is going to be 0. If we have only one 77, this is going to be 11. If we have two 77s, the m is going to be 2. 2 times 11 is 22. And so on. So it can be 33, it can be 44, and I can stop here because I don't want to go above 50. For the n's now, n could be anything, right? So I can start with 0 and keep going up. If this is 11, what should this n be? Well, if this is 11, then this is going to be 30 or 40. Wait, so 50 minus 11 is going to be 39. Right? And then 50 minus 22 is going to be 28, right? And 50 minus 33 is going to be 17. And then this is going to be basically 6, right? So if we do this, then the question is, what could n be? Well, n could be, wait a second. Which of the following could be equal to n itself? So we're asking for this n, which is, so this n is basically, okay, let me apologize. I used n as the number of 7s in the equation, but this n is actually assigned. This n is different than this n. This n is basically how many terms do I have? And the number of terms is basically n plus m in my, how I assign the n and m here. So basically what I'm looking for is what is n plus m, right? In this line, n is 0, m is 0, the sum is 0, right? So n plus m is going to be 0 for this line. For this second line, 39 plus 11, for 39, the n was what? N is 39, and the m is 1, right? This m is 1. 1 times 11 is 11. So 39 plus 1 is going to give us 40. So the sum is 40 in this case. In the third line, n is 28, and then m is 2, because 2 times 11 is 22, right? So 2 plus 28 is 30. And if you continue, this is going to be 20, and this is going to be here, it's going to be 10. So basically the sum of the terms, which is this n that they're asking you for, which is basically how many total terms do we have? What is the sum of all the 7s and all the 77. I mean, not the sum, but how many do we have? How many terms do we have? What is n, right? So in this case, the only one that matches is the 40, right? So here again, I used n here, but this n is different than this n. This n is how many terms we have, and this n here, the way I used it here, I defined this n to be the number of 7s in the sequence, right? How many 7s do we have? Okay, so hope this was helpful. So let's move on. Again, if you have any questions, please don't hesitate to leave a comment or send me a private message. All right. So now let's start with this question. Let me clear the board. All right. So this is a sufficiency question. Okay. So don't forget to pause if you want to try it on your own, which I highly recommend you to do so. All right, in the xy plane, does the line with the equation 3x plus y, so y is equal 3x plus 2, contains the point RS? Okay, so basically the line is defined, right? So I can actually draw it. I know that the slope is 2. I know, and the slope is 3, sorry, and the y-intercept is 2. So I know the point 0, 2 is on the line, and I know that the slope is 3. And the question is, does this line contain this point? So so what's rephrasing this question? It's asking you, is this point on this line? So how do I test if it's on this line? Basically, if I put the r and s in the equation, they should be equal. So how do I rephrase this question? I rephrase this question by replacing this x with 3. So in the cases where x is actually an r, right, and plus 2, am I gonna get a y that is equal to s, right? So this is how you check whether this point is on the line. We check it by plugging in the x coordinate for x and see if the output, right, of this function, the y, is going to be equal to the s, which is the y coordinate of this point, right? So this is basically what the question is. So I can rephrase this question by saying, is s equal to 3r plus 2? So this is the question, right? So if you look at the first statement, the first statement is something, an equation, and it's a quadratic equation that has a 0 on the right side. So when will this be equal to 0? So statement 1, if taken as is, I know it's equal to 0, and the only way this is going to be 0 if either this one or both of them are equal to 0, right? So the zeros of this function are going to be when this whole thing is equal to 0, and if this whole thing is equal to 0, I'm going to say 3r plus 2 minus s is equal to 0, right? Or the second statement, 4r plus n minus s is equal to 0. From the first one, the first possibility, I get the same exact equation I'm looking for. I get 3r plus the 2 is actually, if I move this to the other side, to the right side, it's going to be equal to s, right? So it's telling me this is a possibility, but it doesn't have to be 0 in this case. This is just one option, because the other scenario that could make this first statement 0 is when this one is 0, which, if I want to change it, this is 4r plus 9 is equal to s, right? So the first statement is not sufficient just because I have two possibilities. So what makes this equal to 0? Either when this is 0 or when this is 0. If it is the case that this is what is 0, then the answer would be yes. But since I have two possibilities, it means that this doesn't have to be 0, right? That's why the first statement is not sufficient on its own. We go to the second statement, the same thing. I'm not going to write it down, but this is 4r minus 6 is equal, if you move it, because this whole thing can be 0, which means 4r minus 6 is equal to s, or 3r plus 2 minus s is equal to 0. So basically, again, this is not sufficient on its own for the same reason we discussed here. So if we merge them together, so in the cases where neither one is sufficient of these two statements, then I would check both of them together. In this case, if I merge them together, I'm saying that the possibility that this is equal to 0 or this is equal to 0. And the second possibility, this is equal to 0 or this is equal to 0. So when you merge them together, the zeros that are common between these two statements or two equations is going to be the 3r plus 2 equals s. So if you merge them together, the common 0 is going to be the 0 for both, and it's going to be, and the answer is going to be yes, right? Because the 3r plus 2 is going to equal to s. All right, so I hope you get this right. If not, don't worry. What's important here is for you guys to know what you're doing wrong and using these techniques to advance, okay? So I know you can do it. Just keep it up. Okay, so let's move on to the next one. Let's see if we can do 5 questions with this video. All right, again, don't forget to pause if you have to. So this question says the figure shown represents a piece of land that is in the shape of a quarter of a circle or a quarter circle. If the land is enclosed by a fence, again, we're talking about a parameter in here, which of the following is closest to the length in feet of the fence, right? So this fence is surrounding this quarter circle, so it is the parameter of it, right? So if we look at this shape, the parameter is, part of it is going to be this 100 feet plus another 100 feet. But what is the length of this here? So this is a parameter of a quarter of a circle, right? So if this is a circle, the radius of this circle is going to be the 100 feet. So basically the radius is 100. If the radius is 100, then the parameter or the circumference of a circle is going to be equal to 2 pi r, right? 2 pi times the r, in this case, is 100. So basically the answer is 200 pi, right? So 200 pi is the length of this fence here, but we need to add to it this and this, right? So this is another 200 feet. So the answer is going to be 200 pi plus 200, right? And they ask, so now we try to simplify it. So this is an approximate question because they say it's closest to. So we can take 200 out, maybe it's easier. And then pi is 3.14 plus 1. So this is approximately 4.14 times 200. So now this is much easier, right? So it's going to be basically 828, and then times the 100, so basically it's going to be 828. And okay, we did a mistake here. I hope you, so basically I got to this point and think, okay, wait a second, something is wrong. I hope you caught the mistake I did already. So I forgot to divide by 4. So after we found the circumference, this is the circumference of the whole circle, I need to find I need a quarter of it. So I need to divide by 4, right? So basically the circumference of this portion of a circle is 200 over 4, which is basically 50 pi. Right, so this is basically the mistake. So this is 50 pi, right? And 50, maybe we can do it easier. So let me just take this out. 50 times pi is 3.14. So it's approximately, it's over 150. And 150 plus 200 is about 350. And, so it's approximately 357, right? It's not 400 because for it to be 400, the pi needs to be 4, because 4 times 50 is 200 times 200, so it's definitely not 400, so it's 357. All right, so let's move on. Let's try doing one more. All right, so this question can be solved in different ways. Okay, so this one asks, is m plus z greater than 0? So if I'm doing this for the first time, again, I've done these questions many times in the past, so do not measure my recognition of these questions and what method to use with how you're approaching them if you haven't seen these questions before. All right, so if m plus z is greater than 0, so this is the question, is m plus z greater than 0? Well, I mean, I'm not gonna rephrase it, but I'm thinking in the back of my mind, okay, I can rephrase this question and say, is m greater than negative z? I'm thinking to myself, for this m plus z to be positive, either m and z are both positive, or one of them is positive, the other one is negative, but the positive has a larger absolute value than the negative one. I can't have both of them negative, right? So these are just things that you can think of as, very quickly in your mind, just to keep in mind the different methods of approaching these questions. So the first one is telling me that m is greater than 3z, right? Or m minus z is greater than 3z. I'm thinking to myself, okay, so this is telling me that m is greater than 3z. Well, if z is a positive number, let's say if z was 1, right, then m is going to be another positive number, right? And positive plus positive is going to give me a yes answer. So m plus z is going to be negative. It's going to be greater than 0, which the answer would be yes. But what about other cases when, let's say, z is a negative number? Let's say if it's negative 1, right? Or let's say negative 10, right? So 3 times negative 10 is negative 30, right? In this case, m is greater than negative 30. So m could be negative 20. And in this case, the sum of these two is going to be negative. Or it could be a very large positive number, which means the sum is going to be positive, right? So this statement by itself is not sufficient because it gave me a yes and a no for this question here. Okay, so moving on to the second statement. And the second statement is very similar to this one, right? So basically you go and try a few values for 4m. So I would definitely write it as 4z is greater than m, right? It's easier to plug in numbers, right? So if z is a positive number, let's say 1, and so 4 times z is going to be 4, and m is less than 4. So m could be 3, right? And in this case, 3 plus 1 is positive, but m could be a very large negative number, and then the sum is going to be negative. So statement 2 by itself is also not sufficient. And in cases where both statements are not sufficient, then you would try both of them together. So with both of them together, there are more than one way of approaching it. But one of the things I recognize when I'm solving these, I try to see the big picture, right? From the first one, I know that m is greater than 3z. And from the second statement, I know that m is actually less than 4z. And if you notice the similarities between these, right? So m is less than 4 and 4z and greater than 3z. So if you can tell this, if you recognize this, and I've seen this many times. So basically, if I tell you, we know that 3 is less than 4, right? This is a known fact, right? So if at the minute I multiply it with a variable, let's say x, right, and the sign stays as less than, then I know that x is a positive number. So from this, if this is given to me, then I know automatically that x is a positive number, because when I multiplied by this x in this inequality, the sign did not flip, right? If I tell you 3x is greater than 4x, well, 3 is usually less than 4, not usually, always. The minute I multiplied it with x here, the sign flipped. So it means x must be a negative number, right? So basically in inequalities, when you multiply by a negative, you need to flip the sign. So going back to this question, so the minute you see this is for me a sign recognizing this rule, right? And by the way, what I recommend my students to always have a one sheet of paper, 8 by 11, where you write on it in small fonts things that you need to remember when it comes to math. Keep that sheet of paper next to you. I don't like the cards because it's going to take you forever to find them. One single sheet of paper, you're always referring to it, you're always adding to it. Keep it next to you when you're practicing, and then in the exam, just go over it prior to the exam, right? It's a very important, for me, it was very, very helpful, and I highly recommend you to do it, right? So this is something I would definitely write. So I would write on the sheet of paper things like patterns or rules or shortcuts that you can use, or things that you should recognize when you're taking the exam. So with this one, recognizing this fact, I know that if m is less than 4z, and it's also greater than 3z, what does that tell me about m? What does that tell me about z? This is telling me that 3z is less than 4z. Therefore, since 3 is less than 4, multiplying it with z did not change the sign. Therefore, z must be a positive number. If z is a positive number, 3z is positive, 4z is positive, m must also be positive. Therefore, taking together is sufficient because both of them are positive, and m plus z is also going to be a positive number. All right. That's it for now. Good job, you guys. Keep up the good work. And if you have any questions or feedback, don't hesitate to ask me. Bye bye.